Okay, next example, y equals to 8 minus 7x to the power 4. Okay, I don't really like to put it in terms of you. Once you have understood the steps, then you can straight away do the question rather than making u to the power 4. Okay, so let's see how do I do this. Okay, first thing is I'll differentiate dy over dx, which will give me 4 bracket 8 minus 7x, and then 4 minus 1, which is 3, and then you differentiate what's inside. Okay, so you differentiate d 8 minus 7x in terms of x. Okay, you differentiate 8 minus 7x in terms of x. So what I get here is 4 8 minus 7x to the power 3, and then when you differentiate 8 minus 7x, it will give you negative 7. So you bring that forward, so negative 28 8 minus 7x to the power of 3. That's it. Okay, next example. Okay, what if I have y equals to 8 over 2x plus, or 2x squared plus, or maybe minus in this case. Okay, 2x squared minus 3. Okay, how would you do this? 3 to the power of, let's say 5. Yeah, let's make it a little bit complex. Okay, so the steps are still the same. Okay, but instead of you leaving the power at the bottom, I'm going to bring it to the top. Okay, so 8 and then bracket 2x squared minus 3, and remember, if the power from the bottom, if you bring it to the top, okay, the degree, if it's positive, becomes negative. Okay, don't forget that. Okay, so from here dy dx equals to negative 5 times by 8. Okay, and then 2x squared minus 3, and minus 5 minus 1. Okay, and then you differentiate 2x squared minus 3 in terms of x. So what I get is negative 40 bracket 2x squared minus 3 to the power of negative 6, and when you differentiate 2x squared minus 3, you get 4x. Okay, and then now let's simplify this. Okay, so 4x times by negative 40, negative 160x, and then 2x squared minus 3 to the power of negative 6. I don't like to keep the degree in terms of negative, so I'm going to bring this down. 160x, you bring that down, it gives you 2x squared minus 3 to the power of positive 6. That's it. Okay, y equals to square root of 3x cubed plus 1. Okay, square root or cube root doesn't matter, still the same. To change this in terms of power, so 3x cubed plus 1 to the power of half. Okay, remember square root is to the power of half. So when you differentiate dy dx, first step, bring the half in front, and then 3x cubed plus 1, and then 1 over 2 minus 1, and then don't forget to differentiate 3x cubed plus 1 in terms of dx. Okay, so that would give me half. Okay, so the answer is 3x cubed plus 1. Okay, half minus 1 is negative half, and then differentiating 3x cubed plus 1 will give me 9x squared. Okay, and plus 1, that becomes 0. Okay, so when I simplify this, you get 9x squared over 2, and remember this is half, and that's negative. When I bring it down, this is same as 1 over square root of 3x cubed plus 1, which I can rewrite as 9x squared over 2 root square root of 3x cubed plus 1. Okay, y equals to 2 over cube root of 2x squared plus 1. Okay, 2 over cube root of 2x squared plus 1. Okay, differentiate this. Before that, rearrange. Okay, rearrange mean put it in the simplest form, easiest form where I can differentiate. Okay, at this point I can't. Okay, actually you could, but there's another method which you will be learning it later, maybe in P3, but not now. So what you have to do is you have to bring this. First of all, change the cube root into power. Okay, so 2x squared plus 1 to the power of half. Sorry, to the power of 1 over 3. Okay, to the power of 1 over 3, which I can rewrite as 2 bracket 2x squared plus 1, and now the denominator I'm bringing it to the top. It becomes numerator. When it's a numerator, the power, it's no more 1 over 3, becomes negative 1 over 3. At this point you can start differentiating. So dy over dx will give you 2 times by negative 1 over 3 bracket 2x squared plus 1, and then negative 1 over 3 minus 1, and then you multiply by d 2x squared plus 1 over dx. Okay, so this will give you negative 2 over 3 2x squared plus 1. Negative 1 over 3 minus 1 is same as negative 1 over 3 minus 3 over 3, which is negative 4 over 3. Okay, and that would give you differentiating 2x squared plus 1 will give you 4x. Okay, I think that's it. Now we can simplify. So 4 times by negative 2 is negative 8x over 3, and then remember this is 1 over. Okay, you bring that down, it gives you, okay, let's not do the root first, so it gives you 2x squared plus 1 to the power of positive 4 over 3. Okay, so this is same as negative 8x over 3 2x squared plus 1 to the power of 4 over 3. Or if you want to simplify further, you could, which gives you negative 8x over 3 times by root 3. Okay, so 1 over 3. Okay, and this is 2x squared plus 1, and the whole thing, okay, to the power of 4. Okay, okay, those who don't want to simplify further, if you think you'll make some careless mistake, you can leave it here. That's not a problem. Okay, find the gradient of a curve y equals to x minus 3 over x plus 2 at the point where the curve crosses the x-axis. Okay, when a line or a curve, okay, crosses x-axis, y equals to 0. Remember that. Okay, if the line crosses y-axis, then x becomes 0. Okay, so before I differentiate, I want to know where does this curve cuts the x-axis. Okay, where it's going to cut. So to make y 0, so all you have to do, y equals to x minus 3 over x plus 2. So y equals to x multiplied by x plus 2 minus 3 over x plus 2. Let's make this 0. So if I do that, I will be getting x squared plus 2x minus 3 over x plus 2. So when y equals to 0, 0 equals to x squared plus 2x minus 3 over x plus 2, you bring it over, that becomes 0. So you factorize this, you get x, that's minus 3, so it should be in plus 2, so it's plus 3 and then x minus 1. Okay, plus 3x minus 1 equals 0. So x squared minus 3x x squared minus x plus 3x, yeah, that's correct. So x equals to negative 3 and x equals to positive 1. Okay, so now the question is find the gradient. So of course we need to differentiate. Okay, let's do that in the next page. So dy, no, before that, y equals to x minus 3 over x plus 2, right? Yeah, x plus 2. So I'm going to rewrite this. Okay, why am I rewriting? I'm rewriting so that it's easy for me to solve, okay, or differentiate. Okay, if it's in this form, it's difficult for me to differentiate. So that's why we use chain rule, and we know to use chain rule I have to have the number, whatever the denominator you bring into the top. So this should be -1. Okay, so over here it's +1, you bring it to the top, it's -1. Now let's differentiate. So when you differentiate this, the derivative of it is 1, and then plus 3 x plus 2, -1, -1, and then when you differentiate the x plus 2 over, you differentiate dx plus 2, okay, over in terms of x, so you get 1 over there, so it's just 1 plus 3 x plus 2 to the power of 2, and this is 1. I don't have to write that. Okay, so this is this is -2, guys. Okay, -2. Okay, so I'm going to bring this down, 1 plus 3 over x plus 2 square. Okay, from the previous page we already got x equals to -3, x equals to -1. So sub x equals to -3 and x equals to 1 to find the gradient. Okay, so to find the gradient when x equals to +3, -3, y, the gradient is 1 plus 3 over -3 plus 2 square. Okay, at the point where x equals to -3, your gradient is 1 plus 3 over -1. So -3 plus 2 is -1, -1 square is +1, so your answer is 4. Okay, where x equals to +1, your gradient is 1 plus 3 over x plus 2, so it's 1 plus 2 square, and your answer is 1 plus 3 over 2 plus 1 is 3, 3 square is 9, so your answer is 1 plus 1 over 3, which is 3, 4 over 3. That's it, your gradient is 4 over 3. So the answer is at x equals to -3, your dy dx, your gradient equals to +4, and when x equals to +1, the gradient at the point where x equals to +1 is 4 over 3. Okay, thank you.